A relation R is defined on a set of straight lines on a plane as L1 or L2 if and only if L1 is perpendicular to L2. And it's given here that L1 and L2 are straight lines in a plane. Now we need to check for reflexivity, symmetry, and transitivity. Okay, let us begin. Now first, what we'll do, we're going to suppose that let A be the set of straight lines on a plane. We can think of some planar surface, and in this planar surface we have several straight lines lying on the plane. Now we have a relation R which is defined on the set of straight lines, meaning we are going to pick up certain straight lines. We are going to pick up two straight lines at a time, let's say, from this plane, and there's going to be a relation between these two straight lines. The relation is such that the two lines must be perpendicular to each other. So it's given here that if we take two lines L1 and L2, so L1 is going to be related to L2 if and only if L1 is perpendicular to L2. That means we're going to consider all those two lines that are perpendicular to each other, only those two lines. And it's given here where L1 and L2, these are the two lines that belongs to the set A. Okay, now this is a relation that is given to us. Our goal will be to check whether if the relation is reflexive, symmetric, or is it transitive on the set A or not. We need to show that here it is given that R is already a subset of the Cartesian product of A with itself. Then we need to find out whether if the relation is reflexive, symmetric, or transitive. So let's begin with the first one. So we will check for reflexivity. Let's do one thing. Let's consider a line. So let's say for some line, let's say for all lines, let's take for all lines, let's call it L1, belonging to the set A. Here L1 can never be perpendicular to itself. That does not make any sense. A line cannot be perpendicular to itself. If L1 is not perpendicular to itself, this simply implies that L1 cannot be related to L1. And if this is the case, we can say that the relation R is not reflexive. This is not a reflexive relation on A. Reflexive relation on A, because the reflexivity demands that if we pick up any single element from that set A, that then we form the ordered pair. So in our case, the ordered pair is telling us that we need to have a line which is perpendicular to the other line. So here, since the line L1 cannot be perpendicular to itself, so here we cannot form a relation. Let's think of in terms of an ordered pair. So here what we are saying essentially is that we are trying to form an ordered pair of L1 with L1. So L1 comma L1 simply means that L1 is perpendicular to L1. Now that can never be true. This is a wrong statement. So here R cannot be a reflexive relation on A. Okay, let's check for symmetry. Okay, let's say we're going to consider two lines L1 and L2. For L1 and L2 belonging to the set A, we are saying that L1 is perpendicular to L2. So if we say L1 is perpendicular to L2, then can we not automatically say that L2 is also going to be perpendicular to L1? That is always a true statement. So if L1 is perpendicular to L2, then L2 is automatically going to be perpendicular to L1. In other words, what we are saying that if we have a relation L1 or L2, then it must be true that L2 is also going to be related to L1. Hence, we can say, the relation R is going to be definitely symmetric. This is going to be a symmetric relation on, A. Okay, let's go to the final one. This time we're going to check whether if the relation is transitive on A or not. So we're going to check for transitivity. So for transitivity, what we need here are three lines. So let those three lines be L1, L2, and L3. And we're saying that we are picking up this three lines from the set A. Set A contains all the lines on a plane. Okay. Now, let's say if we say if we consider line L1 to be perpendicular to line 2, and we consider line 2 to be perpendicular to line 3, this implies that line 1 is parallel to line 3. We can always think about it visually. So let's say here we have the line L1 and we have the line L2. So clearly L1 is perpendicular to L2. Now what we'll do, we're going to consider a line L3 which is perpendicular to L2. Now since L1, L2 and L3 all lie in the same plane, this clearly is telling us that L1 must be parallel to L3. However, we wanted the case that L1 is perpendicular to L3, but we are getting there. We're getting that they are parallel to each other. So this simply means that if L1 is related to L2, L1 or L2, and we have L2 or L3, that means L2 is related to L3. This is giving us that L1 is not related to L3. So here we can say that our given relation R is not transitive. This is not a transitive relation on the set A.